All right, so we're going to take, so I just want, I've got to tell this to always use C1, and that should fix all those zeros eventually. So now I'll drag this. There we go. All right, so it's called a, it basically, so when I was clicking and dragging without the dollar signs, what it would do, so right now in this formula, I've got, it shows you the two things that are being highlighted, that are being divided. So the blue one divided by the red one. When I put the dollar signs in there, it allows the red one to keep traveling down this column, but it keeps the blue one in that cell. If I didn't have the dollar signs in there, it would have taken this one to be red and this one to be blue. And then this one would have been red and this one would have been blue, so the blue one would have traveled as well. But there's nothing in those, so it's doing division by, or division of 0 essentially by 2, 3, 4, and it's giving me that result of 0. But what that does for us, if we look at this, is it allows us to see these are factors now that multiply together to give me 42 and add up to give me, in this case, 43. Here, they multiply together to give me 42. So these are my factors for this number there. But what's nice is somebody give me, no, never mind, don't give me a number. Okay, so if I change that number to 64, it changes the entire column. Does that make sense? And now it generated all of those factors for me. So what I'm going to do is let's insert a row here, or column. Entire column. Okay, so we are going to, when, my hope is that you use this, I'll let you use this on test, because I don't want you sitting there and thinking, okay, if I've got a number like 112, what are all the factors of that, okay? Type in, and this is the only box you need to adjust, type in 112, hit enter, and now you've got your factors. And remember, the ones that are decimal, we're not going to look at those. We're not interested in those, okay? So, you know, those two multiplied together give me 112. These multiply together give me 112. These multiply together give me 112. And then we can use those, when we look at those in any form, positive or negative, okay, determine what then our factors need to be for our quadratic. So I want to use that because today's factoring gets a little bit more complex than what we've been doing, okay? So if you see in the notes, the title says factoring ax squared plus bx plus c. It says where a does not equal 1. So this number right there is going to be a number other than 1, okay? And that changes the procedure that we go through for factoring, okay? It says if all three a, b, and c are evenly divisible by a, you're going to divide all and rewrite. It says this will make the problem same as the previous section. It should say 4-1, part 2 here. So basically what I'm saying there in this example, do you see my A term right here is not a 1, right? So what we want to do is we want to see, does every other term divide by that number? Does 12 divide by 2 and does 10 divide by 2? So we're going to do that. Now this is the way that we do it. We're going to bring the 2 out, and then we'll write a set of parentheses. And inside the parenthesis, is the result from dividing each of these things by 2. So what do I get when I take 2x squared divided by 2? X squared. What do I get when I take 12x and divide it by 2? 6x. And what do I get if I take 10 divided by 2? Positive 5. Okay? So, right there, those are 2 factors so far that multiply together to give me the original 2x squared plus 12x plus 10. Okay? Do you see how that's kind of undoing this distributive property? If I distribute that 2 through, does it give me back to where I started with? Yeah. Okay? Now, does this thing here look exactly like what we were talking about last week? Can I take 2 numbers that multiply together give me 5 and add to give me 6? What 2 numbers multiply together give me 5 but add to give me 6? 1 and 5. So I'm going to rewrite this as 2 times x plus 1 times x plus 5. And now that's the fully factored version of that quadratic. Yes? Probably around 8 to 10. Okay, so that is the first thing that you're going to want to see or try to do when the A value is not 1. And basically what we're doing there is we're factoring out a GCF. G greatest C common F factor, greatest common factor. And the greatest common factor here was 2. Okay? And then hopefully that results in something that we've already worked on. Okay? Now I'm going to skip all of this. Okay? But this is the proof of why what we're about to do works. Okay? But I'm not going to get into that right now. I think maybe it makes more sense just to see the procedure, and then eventually maybe we'll come back to this once we've learned the procedure, and this will be easier to understand why it works. These are the steps that we go through to do this, and these steps are here if you get stuck. So if we're on a quiz at some point and one of these shows up, you know what to do. You got these 8 steps. Okay. First thing you're going to do is you're going to multiply the A and the C values together. Okay. This is called the AC method. Okay, because of that first step, multiplying A and C together. Okay, that's going to give you a product. You're then going to try to determine factors of that product, AC, that add up to give you your B term. Okay, it's very similar to what we've been doing, except for instead of looking at just the things that multiply together to give me C, we're going to be looking at the things that multiply together to give me AC. Okay, so you're going to rewrite AX squared plus BX plus C so that B is written using values found in step 2. So we'll talk about that here in a moment when we do an example. You're going to group things. Okay, you'll group the first 2 items in your list because this will generate 4 things. This line 3 here will generate 4 terms. You'll group the first 2 of the set of parentheses. You'll group the last 2 of the set of parentheses. And then in each one of those groups, you'll factor out a GCF. Okay? When that happens, because what is left in parentheses should be the same. Okay? That ends up being one factor that divides the original quadratic. The second factor will be everything that is left over that is not in parentheses. Okay? Again, a lot of these steps will make more sense once you see a specific example. And then we'll write our final statement as a product of 2 binomials. Okay, so first example here. Obviously, we see this 6 here. And the first thing we're going to try, because this technique is more time-consuming and more difficult than what we've been doing, and if we can avoid it, we want to avoid it. So the first thing we want to do is see if does everything up there divide by 6. And 23 and 7 neither divide by 6, right? So we can't use that tool. We can't do that. So what we're going to do is we're going to take, this is my A term, and this is my C term. So A times C is going to be 6 times 7, which gives me 42, right? Okay. This is where I want you to use the Excel sheet. I'm going to just open that Excel sheet up. In that box right there, type in 42, hit enter, and it will give me my factors of A times C. Okay? And because of this process, this A times C number is usually going to be pretty big. Okay? The examples I've been trying to give you in the previous sections, that number, that C term hasn't been huge. But now you're multiplying it by something else, so it's going to get larger quick. Okay, so this tool will be useful. Which one of these factors, sets of factors, add up to this middle term here? Remember the factor, so 1 and 42 are factors. Do those two add up to give me 23? Yeah, those two are the ones that add up to give me 23, right? So those are the ones I'm going to choose. So this is where we come into step 3, okay? So the numbers I'm using here for 42 are 2 and 21. In step 3, it says rewrite ax squared plus bx plus c so that b is written using these two values. So all you're going to do is you're going to write 6x squared. And this is the same every single time. This bx is now going to be written using those. So I'm going to rewrite it as plus 2x plus 21x. And my plus 7 stays the same. Okay? Now the 2x and the 21x, it does not matter the order that you do that. Okay? So your neighbor could have 6x squared plus 21x plus 2x plus 7, and they're going to have a little bit different work than you, but we're going to both arrive at the same answer. So that the stuff in red there doesn't matter the order. Okay? Is that okay with everybody? The next thing you're going to do, and you can put parentheses, I like to highlight using this program, but I'm going to look at those two things right there as one group, and then I'm going to look at these two things. Okay? And what I want to make sure is that I group them with their signs. So in this second group, that sign right there needs to be in the parentheses, whether it's positive or negative. And now in that blue set of parentheses, that blue highlighter, what can I divide both those things by? What is a GCF for the things that are in blue? 2 and what else? They both have a 2 in them, I agree with that. But don't they both have an X in them? Does that make sense? So when we look for GCF, it's not always just numerical. It could be variable as well. So everything divides by 2 and an X. So I'm going to take a 2X out. And that will always be the case in the ones that we see right now, is that first thing that you divide out will be like a 2X, a 3X, a 4. There will be an X with it. Okay? So now, what is 6X squared divided by 2X? What's that? What's 6 divided by 2? 3. And then X squared divided by X gives me X. So that gives me 3X. Good. Okay? What is 2X divided by 2X? 1. Okay? So remember, that's all we're doing here when I say factoring something out, is that I decide what I'm going to factor out, and then what is left right here is the quotient of that and what I divided out. So 6x squared divided by 2x gives me 3x. Because we should be able to distribute to get back to what we started with. I should be able to take that 2x and multiply it through 3x plus 1 and get back to the blue set of parentheses. Okay? Now, look at the green stuff. Okay? What divides both those things in green? Careful. I think that's what you're thinking. 7, but does it 3 times, right? So 7 will divide that, and 7 will divide that. So I'm going to take out of 7. If I take 21x and divide it by 7, what's it give me? 3x. And what's 7 divided by 7? Positive 1. Okay. And this is where it gets us down to, so we just did 5, which said factor the GCF out. Now here it says what is left in the parentheses should be the same statement. Would you guys agree that that there and that there are identical? Okay. If you've done this correctly, that is the identifier that you're almost home. You've almost done it. Okay. You're going to write that down in one set of parentheses. So 3x plus 1, that becomes one of my factors. Okay, and that's what step 6 says. Step 7 says everything else, which everything else would have been the 2x and the plus 7. Does that make sense? That becomes another factor. And that right there is how we factor 6x squared plus 23x plus 7. Okay? Now, would you agree that that's a long process? Okay, so I like to know, after I've put in that amount of work, I like to know, am I right? Did I do it correctly? So if I ask you to do this on a test or a quiz, my hope is that you would grab Desmos and check this. If I go 6x squared, all I'm going to do is type in the original. And I'll type in then what we just came up with, 3x plus 1 and 2x plus 7. Okay. Now, right now, it's got these little warning signs in it because it doesn't know what x is. But if these are the same thing, just alternative versions, I should be able to plug x in and it give me the same number back, right? So if I take x and just say x equals, and just choose a number like 5, do you see how in the top one it evaluates it at 272, and in the bottom one it evaluates it at 272? So that tells me that those two versions, this version here and that version there, are the same because these two numbers were the same. Okay. Now, does it work with 54? Does it work with 542? Okay. It works with any number that I choose. Does that make sense? And that guarantees me that I've done things correctly. Okay. Does that make sense? Okay. Now, the hope is the only thing that is different from problem to problem is whatever that AC is, okay, and determine what its factors are. Once you find those, the process is identical every single time. All right, so let's do this next one. Okay, what am I going to get when I multiply A and C together? Yeah, so 5 times 2 gives me 10. Okay, now on some of these, my hope is that you don't necessarily need, here the 10 is pretty small, but if you want to use this, okay, which ones add up to give me 11? 1 and 10, right? Okay, so 1 and 10 are going to be the numbers that I use. I'm going to go 5x squared. That stays the same. The 11x gets rewritten as the sum of those two things, so 1x plus 10x, and then plus 2. Do you guys remember foiling the O and the I? If I foiled O and I, eventually became like terms, right? Okay, and then we added those together. The things in green right there, the 1x and the 10x, those are the O and I, kind of working backwards. This is how we find the correct O and I for that foiling process. Okay, so now I'm going to group these two. And then I'll group those two. Again, I just like to highlight so I'm easier to talk about. What can you divide out of the yellow group? Okay, so they both have an x, right? An x to the first power. So I'm going to take an x out. Okay, is there a number that goes into 5 and goes into 1? Just 1, right? So if you want to write 1x, you can. But a lot of people just write x. So that's all that will divide 5x squared and x. So if I divide 5x squared by x, what's that going to leave me on the inside here? 5x. If I take 1x and divide it by x, what's that going to leave me? Plus 1. Okay. Now in the back set, in the green ones, what divides both those terms? 2. So what is 10x divided by 2? What's going to be left over here? 5x, and then 2 divided by 2 gives me 1. Again, the goal is for what to be in the parentheses to be the same. So that becomes one factor. And then x plus 2. Where you can only factor out just one thing out of like the yellow or one thing out of the green. Is that what you're saying? Yes. The way this will be set up right now is that this will always, with Math Excel, they'll always be factorable. I'm not sure if I've got. We'll see one eventually to answer your question where if if you don't recognize, so if I had something like 3x plus 5, there's nothing that can factor out of both those, right? So what we always do is we say, well, nothing bigger than 1 will factor out, but 1 always factors it, right? So we'll factor out a 1, and it doesn't change this, but it gives me something that's on the outside, like this plus 2. You'll give me a plus 1 that I can attach in the second set of parentheses. So that's the one kind of situation where it's almost easier work, but people miss it because we're always looking for something that is bigger than 1 that divides through that we're used to. All right, so let's do this next one. All right, so what's 3 times negative 15? Three times 15? No, what's 3 times 15? 45. And one's positive, one's negative, so it's negative 45. So when we're looking at, and this is the only issue with using Excel here, I'm looking at 2 numbers that multiply together to give me negative 45. So one of these factors in green here has to be positive, the other one has to be negative. That's all that is saying. So of these, if one of them is positive and one of them is negative, which grouping will add to give me 4? Basically asking which of these values are 4 of these factors, which one are 4 units apart from one another? Are 1 and 45 4 units apart? Are 3 and 15 4 units apart? Are 5 and 9 4 units apart? 5 and 9. So there's my 2 factors, 5 and 9. Okay, so my 2 factors are 5 and 9. Now, which one needs to be positive so that when I add them, I get positive 4? Is it negative 5 and positive 9, or is it positive 5 and negative 9? Which one of those groupings gives me positive 4? Negative 5 and 9. That's the one I'm going to use. So we're going to take this and we're going to write as 3x squared minus 5x plus 9x and minus 15. We'll group the first 2, set of parentheses. We'll group the back 2, the set of parentheses. So what comes out of the yellow ones? Does anything dividing number divide 3 and 5? So we're just looking at the variable x then, right? So x will divide both of them, leaving me with 3x minus 5. What divides both of these numbers here in blue? 3. So plus 3. 9x divided by 3 is 3x. Negative 15 divided by 3 is negative 5. And now I get x plus 3, which is the stuff on the outside. That's one factor. And then the stuff on the inside was the same, so that's another factor. And the whole idea here is if I FOIL that and combine like terms, it gets me back to 3x squared plus 4x minus 15. Now, I want to demonstrate with this one. This will be the last one we do, obviously. I want to demonstrate that the order that we wrote these doesn't matter. So if you would have written it as 3x squared and then plus 9x minus 5x minus 15, you still would have grouped these 2, and you still would have grouped those 2. Does that make sense? Okay. What divides these 2 now? 3 and a x, right? So 3x squared divided by 3x is x. 9x divided by 3x is 3, right? I'm not sure. How many, or what number divides this? 5 divides them both, but because that sign's a negative right there, we're going to divide by a -5. What's -5 divided by -5? Be +1, right? What's -15 divided by -5? +3. Did what we end up with in the parentheses end up being the same? Okay, so x plus 3. And the stuff on the outside, 3x minus 5. My hope was that you see that the work here is a little bit different than what we saw over here, correct? But was that answer and that answer the same? So the order that you write your factors when you rewrite your B term, it doesn't matter. Okay. Tomorrow, like I said, and we can do a little bit of, because tomorrow will be a full hour, which we don't usually have, or full 45 minutes that we usually don't have when we take a quiz. So I'll leave it up to you. If you want to come in tomorrow and do some review before we take it, we can do that. But I will still write it to where it should only take you about a half hour. Okay, all right. Just come tomorrow. We'll make sure you've got it. But we're just gonna. All I'm gonna do. I'm just asking you. Like if I take like x squared plus 5x plus 6, I'm gonna ask you to factor that. That's all the questions are gonna be tomorrow. Is that right? We need to have some proficiency with factoring so we can move through really the rest of the course, because that's what a lot of the rest of the course involves.